So there we are. We'll pass over to Kurt to talk about LUMI and EasyBuild.
Okay, so good afternoon, good evening, good morning, or good night, depending on where in the world you are. I will present you LUMI, which is one of the European pre-exascale systems, and our early experiences with EasyBuild on it. So I am Kurt Lust. I work at the University of Antwerp, but from my position in Antwerp, I work half-time for the LUMI user support team, which also happens to be abbreviated LUST. So maybe first disappoint a few people. What this talk is not about. Well, don't expect a talk about sophisticated workflows with automated quality testing, because we've only been on the system since October 13, 2021. So we don't even have a finalized directory structure yet, and we don't have test notes yet. That's all still under construction. Also, don't expect a talk with a lot of information about how we deal with the AMD GPUs, basically because we have almost no GPUs at the moment, and not yet the final ones, let alone that we have any information about the finished programming environment. The first information that we got was like last week, basically from the documentation site of Crusher, which was published. Crusher is the early access platform for Frontier, which is an American exascale system and the big brother of LUMI in architecture. So LUMI is a European project. European projects often means that funding partly comes from the European community and partly from countries that participate in the project. So that's no different for the pre-exascale systems. There are 3 pre-exascale systems being built. So ours is LUMI, which will be hosting or is hosting a data center in Kajaani in the middle of Finland. Then there is Leonardo, built in Italy by Cinica. And then there is Mare Nostrum 5, which will hopefully ever be built in Barcelona if they manage to finish the procurement successfully. So it's a joint investment of Euro-HPC, joint undertaking for 50% of the money, and then a consortium. Each of those 3 hosting countries has built a consortium of countries to fund the other half. So in the case of LUMI, we are 10 countries, essentially the Nordic countries. So Finland, of course, Sweden, Norway, Iceland, Denmark, and Estonia, and then Poland, the Czech Republic, Switzerland, and Belgium. The resources on LUMI will be allocated proportional to the investment. So half of the resources will be allocated by the Euro-HPC joint undertaking, with a similar program as Cray's Tier 0 access. And in fact, the first round is being managed by Cray's. On the other hand, each LUMI consortium also gets its own share, depending on how much they invested. And they can essentially set their own policies for the national access program. And in fact, even user management is distributed. There is no central user and project management. They've built a distributed system where each country enters its own projects and manages its own users. So LUMI is the Finnish word for snow. It's also a character in one of the fairy tales of Henrik Andersen, but it also stands, and now comes the marketing talk, for large unified modern infrastructure. So it's essentially a Tier 0 GPU accelerated supercomputer, and it aims to enable the convergence of traditional high performance computing, artificial intelligence, and high performance data analytics. To that end, the main compute partition is called LUMI-G, is a GPU partition with around 500 petaflops vector performance FP64, coming from over 10,000 AMD MI250X GPUs. I say around because, okay, I'm kind of allowed to say the exact number if I would know the exact number. The tender was like just over 500. Then when we saw the first information about MI250, it was just below. But then if you look at the specifications of Crusher, then that again gives a number which is higher, as if Cray is allowed to overclock. So I don't know the exact number. That's vector performance. The thing also has matrix units, also for FP64, which are twice as fast. But again, that's a very theoretical peak speed because the system simply doesn't have the memory bandwidth and large enough caches to keep those units fed. So we expect a LINPACK performance around 375, 400 petaflops from that partition. Then we have a supplementary CPU partition with on the order of 1500 nodes, again with AMD CPUs, 2 sockets, 128 cores in total per node. So that makes for about 200,000 AMD EPYC cores. So these are the two main compute partitions. Then there is what we call the LUMI-D or data analytics partition, which is mostly meant for more interactive work. So it has 8 nodes with 4 terabytes, no GPU, and then there's 8 nodes with, got better, instead of AMD GPUs, they've put in NVIDIA GPUs just to make it a bit more fun for us to install software for different architectures. And then there is another small partition, which is called LUMI-K, where the K stands for Kubernetes, which is really a container cloud service. It's mostly meant to run containers that service the rest of LUMI, like a Galaxy portal and so on. It's not really meant to be your big cloud resource for bioinformaticians or so. If they were hoping to be running only on that or to get projects that only use LUMI-K, that will not be possible. So that's for the compute resources. Let us also consider the storage resources. We have 3 storage systems. The first one is called LUMI-F, where the F stands for flash, which is like 7 petabytes of flash-based storage with an I/O bandwidth of around 2 terabytes per second, and hopefully good IOPS also. Of course, it's running a parallel file system, Lustre, so that means that, I mean, you don't have to hope that on a single thread you can open and close thousands of files per second. That's not meant with IOPS here, of course. Then we have LUMI-P, which is a traditional disk-based parallel file system, metadata on flash. These are really 4 20 petabyte systems rather than a single 80 petabyte system. So if one falls out, we still have the other 3 to run on. And then there is LUMI-O, which is an object storage service with 30 petabytes of disk space, maybe extended in the future, running Ceph, but we're still setting up that system. And so all those partitions are connected via high-speed interconnect, which in the case of LUMI is the new Slingshot interconnect from HPE-Cray, which is an Ethernet-based interconnect, but with various extensions for better performance on small messages, for better performance if the system starts to saturate, and so on. And then there is room for experimental extensions also. So the hope of CSC is to also acquire a small quantum computer which would be linked to LUMI, which we now already call LUMI-Q. Let me quickly go over the compute node configurations of the main nodes. LUMI-C is pretty boring. That's just your standard 2-socket AMD node with per socket 8 chiplets with 8 Zen 3 cores, 32 megabytes of shared L3 cache, each core, of course, having its own L2 cache. LUMI-G is the more interesting part. This is really like, I would call it the GPU first system rather than a CPU with GPU accelerator. So it has 4 sockets is not exactly the right word, but maybe I should use packages, GPU packages, MI250X. Now each MI250X actually has 2 GPU dies in the package, with each die having 64 gigabytes of HBM memory, so 128 per package or 512 gigabytes of HBM memory for the node as a whole. Those 2 dies are connected to each other via AMD's Infinity Fabric, so the same fabric as they are using in the EPYC CPUs, except that it's already running at a higher speed than the current Zen 3 generation EPYC processors. The same interconnect is also used to connect the GPU packages and is also used to connect the GPUs to a special version of a Zen 3 CPU. So it's special in the sense that they don't say much, but I think it's really a different I/O die, because that Infinity Fabric runs at a higher speed than what's currently possible with the regular Zen 3 CPUs. And that has all the RAM attached to it. But so since everything is Infinity Fabric, sorry, should I say, I've used the wrong word a few times, connected, you have a single memory space, cache coherence across the whole node, and so on. Also interesting to note is that the interconnect, there are 4 network cards per node, are not connected to the CPU, but are directly connected to the GPU, 1 per package. So this really starts looking more as a GPU system with a CPU accelerator for running the operating system and sequential parts of code than a CPU system with a GPU accelerator. The third interesting element is the organization of user support on LUMI. So we have a centralized virtual help desk run by CSE Finland, but it's also run by a distributed LUMI user support team. So we have like a network of dedicated LUMI experts, where each partner country, except for Iceland, which really has the smallest share, contributes 1 FTE. That does not mean that I'm paid by Belgium to work for LUMI. I'm really paid from project funding. So my university pays me, but gets reimbursed by CSE Finland. Besides first and second line user support, we also provide end user training. We maintain the software portfolio. We develop user documentation and so on. Level 3 support comes from various channels. So LUMI is hosted not just by Finland, but by a consortium of countries, and all consortium members are kind of expected to contribute a little bit to the support also, and mainly the higher level support, like application enabling, methodology support. So that can come from the local HPC centers, that can come from the Euro HPC competence centers, and like all big supercomputer projects, of course, we also have a team at the manufacturer, so at HPE and AMD, to assist in porting, in advice, and so on. Besides that, since the allocation of compute time and accounts is completely done on a national basis, support of that should also be done on a national basis, simply because in the central system, we don't even have access to enough data to help those people. So it's really like 11 computers in one for each participating country, and then the Euro HPC part. And of course, as you can imagine, Belgium makes things even a bit more complicated by having 2 access portals. And then the Danes decided, look, we can do even better. We can have even more. Now, given that, so we have a number of boundary conditions. First, we have a fairly experimental and inhomogeneous machine with a new interconnect, a new GPU architecture with an immature software ecosystem. And I'm not only talking about developer software, but also applications, because it's AMD, so it doesn't run CUDA, but a CUDA clone, which is far less capable. It hardly runs OpenACC. We only have one compiler that partially supports OpenACC. Instead, you should use OpenMP and so on. Some NVIDIA GPUs thrown in the mix, and we have a mix of Zen 2 and Zen 3 CPUs to make it complete fun. Of course, those CPUs are very close together, but on a machine which is that expensive, you may want to do processor-specific optimizations when you install software. We've got users that come to LUMI from 11 different channels, which does not count sub-channels. Like in Belgium, we have 2 channels, and in Denmark, I believe they have like 5 or 6 access portals. We've got a small central support team. Considering the expected number of projects and users, we're really only 9 FTE with a lot of tasks. Of course, the consortium should contribute a little bit, but still it's like support-wise, we have an extremely small team, especially if countries would start to use their share as a tier 2 machine rather than a tier 0 machine. The Cray Programming Environment is a key part of our system. It stands front and center, and it's that environment that we get support for from Cray and HPE. Of course, it's not only with the Cray compilers, we have the GNU compilers in it also, and we have the AMD compilers also in it. There's a little operational issue also. They decided that they were too concerned that running the whole software stack from a single file system would create both a point of failure and a performance problem on a machine that size. So they decided to design the machine in such a way that the software is fed from 4 different copies. So each quarter of the node is connected to a different copy of the software stack, which again creates management problems. So what are we looking for given all those constraints? We want a framework that allows collaboration and testing software as a regular user, because none of us people in Lust, let alone people from local support from the countries, have high elevated privileges. We run as regular users. Yet we want to be assured, of course, that whatever we prepare can easily be installed centrally and will run. We also want an easy way to pass software installation instructions to the user. As I will argue later, we don't want too much in our central software stack because that creates too many management problems. However, on the other hand, neither us people from LUS, the LUMI user support team, nor the national support teams can write in the project directories of regular users, unless they would decide to add us to their project, of course. We also want an easy way for developers of software or application experts, for instance, in the national support teams, to contribute software to the LUMI community. And of course, we want a tool with a community for support and continued development. We don't want to do all the development work ourselves. So then, of course, comes the question, should we go for EasyBuild or should we go for the 900-pound gorilla in the room, Spack? There is a very, very big argument for Spack on LUMI, and it is simply Spack is better supported on Cray and AMD, thanks to Frontier and El Capitan, the big exascale projects in the US, with Frontier having essentially the same hardware as LUMI has, only much more of it, and El Capitan is then has the next generation AMD CPU and GPU. However, there's a lot to say for EasyBuild also. First, EasyBuild definitely seems more popular in LUMI consortium countries. And don't forget that Switzerland, CSCS is also in the consortium. Second, the whole point of EuroHPC is that they want to develop a European supercomputer ecosystem with lots of technologies developed in Europe, both hardware-wise and software-wise. So it will definitely be appreciated that we have chosen for a European product there to work on. Community engagement, I think, is also easier with EasyBuild simply because so many people are in more or less the same time zone as we are. There is also the argument that Spack may be more a developer's tool and EasyBuild may be more a support person tool. And having looked at both, I kind of have the same feeling. I also feel like Spack, in the days that I was working on a code in my PhD, would have been a wonderful tool to quickly create all possible combinations and try them out. But that's not what you want the user to confront with. You don't want to confront the user with 40 variants of the same program. Another argument for me for EasyBuild, one that you don't often hear, but easy config files offer a very easy mechanism to document modules, to add help information to modules. And that for us is the most efficient way to spread information. Of course, it looks nicer in a web-based documentation, but keeping that up to date, and you are editing software installation recipes in one system, editing a website in a different system, and you can see that it's not going to happen. Developers are just much more tempted to adapt something if they can do everything in a single file, in a single system. And last but not least, I think as long as things are done in easy config files, it's very easy for different teams to work on the same software package in different configurations. It becomes a bit harder, of course, when you start doing things in easy blocks, because then you have to merge two different implementations of the easy block back in one. But so easy config files, to me, are very easy to do a lot of that. Let me quickly tell you about some policies that we have. So which software do we decide to install? Well, so far we've been working both proactive and reactive. Proactive, we've installed a large set of libraries. I'm sure I'm not using all of them yet, but I've based myself on lists of, for instance, at CSCS, to make a large set of libraries already available for people to install software on top of it. And then also we've prepared our EasyBuild recipes for some packages that did prove popular in our service. Currently, we don't install them in the central stack, most of those packages, because we want to test them further. We've had too many experiences, and several of us have had too many bad experiences with packages that you compile, everything goes well, until you start running complicated cases and users start reporting all kinds of problems. Reactive would then be based on tickets, and of course there we first let the user install it in their home directory before project directory, before we even consider installing it centrally. A few caveats when we talk about Conda and likely much of Python and R. We will almost force users to do that in containerized builds or similar technologies, simply because we don't want many users each have 150,000 of small files of a Conda installation on our parallel file systems. Sysadmins are really concerned that this may hamper the performance of the parallel file system as it starts to fill up. And it's not like EasyBuild or the highway, no. We also consider Spack for some software packages, certainly for user installs, manual install if it's really needed, if we find no way out. Second policy is that we go for a fairly limited central stack. And in fact, in many of the tier 0 systems in Europe that I've worked on for a praise benchmarking project, I noted that there is not that much software installed centrally. To me, one reason is avoid having too many variants and versions of the same package, like you have lamps with different sets of plugins that can possibly conflict with each other, or then you have a user who says, ah, no, this constant in the source file needs to be changed for me. Obviously, if you have too many of those variants, users don't know anymore what to take. There's also a management problem. Which software should we carry on to the next version of the stack? We expect quite frequent updates from the compilers, and definitely that it will be needed to follow some of those updates rather quickly, especially on the GPU nodes, because that software is so immature, which means start building a new stack. Probably they are the right moment to update versions, but there is no way that we on LUMI can know our users the way that the University Tier 2 support team can know their users. I mean, if in Antwerp, when I talk, there's someone in the group who has been there since the beginning, and he kind of knows, okay, this package that's going to be this group, I know this guy has left, you can remove that. On LUMI, with people coming in from all those different channels without much communication with us, there's no way to know that. Now, user installs do lead to duplication, but it also needs to automatic removal. If a project is finished, the project directory 3 months later is removed, and so the package is removed. Moreover, on LUMI, we build storage, not financially, they get an allocation by the hour. So there is a slight incentive for users to clean up every now and then. Another thing is that removing a faulty package is hard. There's 4 copies of it. Users may be using it on a big system. It may work for other users. So you would have to add a corrected version next to it, and you quickly start to build up a pile of trash that way. There's also a slight management problem, since at the moment we have 4 copies. At the moment, we still do not have a dedicated master. There's still system staff, sysadmins are still figuring out how they will realize that for us, which means that if I now install software, it appears first on like 1 login node and a quarter of the compute nodes before I can push it or rsync it to the other copies, which is kind of annoying. A package may be available for a few hours. People may think it's there already while it's not yet there on most compute nodes. And it also eases license management, as it becomes the responsibility of the principal investigator and members of the projects. For most software, we will actually work with a bring your own license model. We do have a considerable software budget, but if you ask people what software they want, you get such a long list that you can spend basically any budget you can think of on buying software. And of course, they mention the most expensive packages first, because they see that as the way to get those packages. Also, more and more codes come with restrictions, even for academic use. Even if they are technically free, you may have to first register as a user before you can use that. So we want to avoid that management burden. Also for VASP, for instance, if you would have centrally one installation of VASP with a big group, then how are you going to manage that group that has access to VASP if people come in from so many different channels? So we organize our software in software stacks. We basically have the Cray Env software stack, which is really just a Cray environment as you get it on a typical Cray system, except that we install some additional software on top of it, not via the operating system, but I push it in via a backdoor by EasyBuild. And then we have our LUMI stacks, where each one corresponds to a particular release of the programming environment. So we do have to work with the native Cray programming environment modules. There's no way to install the Cray PE through EasyBuild. Of course, we also stick with our 4 versions because we have Zen 2 nodes, Zen 3 nodes, Zen 2 with NVIDIA GPU, and then Zen 3 with MI250X. So unfortunately, we stuck with 64 sockets of Zen 2, and then there's 3072 regular CPU sockets of Zen 3, and then 2560 of that special purpose version for the AMD GPU. We may install some software outside those stacks, like ARM Forge will be used both in Cray and in all the LUMI stacks, so we may incite that a bit on the side. And in the future, we hope to start later this year with a stack based on the common EasyBuild tool chains the way they are. The big problem there may be MPI to get it to work with the slingshot cards. And actually, with our current Slurm installation, there also seems to be a problem. It doesn't seem to work together very well with OpenMPI. So now that we have our software stack, we can talk about modules. Now you would say strengthening the European ecosystem, so you must be using environment modules 5. Well, no, we are not. Cray only supports the prehistoric environment modules 3 or a very old Lmod 8.3 version. So we decided to stick with Lmod because we like the hierarchy. Cray uses the hierarchy in a very unconventional way, but I also prefer writing Lua modules over TCL modules, in fact. So the whole LUMI stack is implemented as a two-level hierarchy. There is the LUMI module with the LUMI stack version, and then there are the 4 partitions that correspond to the 4 hardware configurations. And then I have 3 pseudo partitions that I have no time to talk about, but these are for certain special installations. And then on top of that, we run EasyBuild in a flat naming scheme. The whole implementation is relocatable, so for test purposes and so on, we can just put the repository somewhere, initialize a few environment variables to tell Lmod the root module and to tell Lmod where to find the site package, and we run an independent software installation. User modules are integrated completely transparently in that setup. So all the user has to do is set an environment variable that points to the place where they want to install software. We have them to ask, the default is actually in their user directory, but the better place is the project directory, which is shared by all users of a project. But we have no way to know the project directory of a user, since a user may have multiple project directories. The structure of the module tree is, of course, imposed by us, but it mirrors the central stack. But EasyBuild takes care of that. And after that, the user gets an almost unified view of both the centrally installed modules and the user or project modules that they have installed themselves. So whenever you load the LUMI module, you automatically get both the centrally installed modules and the modules that are in that module repository pointed to by the environment variable. We also provide several presentations, a more user-friendly one with nice labels or just the bare directory as most people are used to. By default, we hide a couple of modules that are irrelevant for all but expert users, but you can unhide them, and rather than having to remember all the Lmod variables that can do that, I do it via modules. Again, this is a generic implementation, so I have just a single implementation of the LUMI module, just a single implementation of the partition module, but I link to them in different ways, and I use Lmod introspection functions so that the module can determine what it should do. A single implementation makes it much easier to make consistent corrections on the whole system, rather than having 4 copies of a module after installation and having to make the same change mutatis mutandis in all 4. So now that we have the modules, we can run EasyBuild on top of it. What we do is actually fix the version of EasyBuild for a given version of the software stack. And each version of the software stack is bootstrapped from scratch so that it can be installed completely independently in a test copy of the LUMI software stack. I prefer to stick to a single version because even minor updates of EasyBuild sometimes introduce compatibility problems with EasyConfigs that you had or that you have already installed. And if we ever need to quickly reinstall the software stack, then that's not the moment that you want to figure out which version of EasyBuild you used for which package. To configure EasyBuild, we actually build a module that configures EasyBuild through the range of environment variables that you have available. This is again a single module for the LUMI stack that we link to with different names, like EasyBuild Production, if you want to install in the central stack, and EasyBuild User is the user version. Again, a single piece of code is definitely more complex, but it's easier to ensure consistency. So if you make a change to something, to a location of something in the system part of our EasyBuild configuration, it automatically also appears in the user part, while otherwise you make a change to one module, you forget to adapt the other one. I actually started with 2 different modules and I ran into exactly that problem. It picks up where to install software simply from its name, so whether it's linked with EasyBuild Production or EasyBuild User, and its location in the module tree. So we maintain 2 repositories. LUMI software stack, you will recognize the structure of that one because it's very similar to the repository that CSCS provides for their system. So it contains both all Lua code and our EasyBuild setup and our easy config files for what we install centrally. And then we have a second repository, LUMI EasyBuild Contrib, which is for all software that we do not yet want to install centrally, or maybe never want to install centrally. Like you have those packages like OpenFOAM, Yambo that are quite popular, but you always have problems with them. So how do you install GROMACS in that system setup? Well, at the moment, there is no central installation, but it's really easy for the user. So you load the LUMI module. 21.08 is the version of the Cray programming environment that we use at the moment. The partition module will actually be loaded automatically, but if you want to override or cross-compile, you can also specify it. You load the EasyBuild user module, and then all you need to do is point EasyBuild to the configuration file that we have for GROMACS and -R for the robot, so that it goes looking not only in the current directory, but also in EasyBuild Contrib and LUMI software stack, and that it also installs the dependencies. This one actually has a Plummet dependency. So if you type those commands, you first see, you load the modules. My EasyBuild module actually prints some information about where it will install, so that you have an additional control that all your variables are set correctly. Then you run the EB command, EasyBuild starts. Okay, I've put a lot of dots there because I don't want to show you all the output, and hopefully it will end with build succeeded for 2 out of 2. So then you check your module tree, module avail, and what do you see? Of course, you get the Cray modules. I didn't print them all. And then you see your EasyBuild managed user software, and there your GROMACS and Plummet module appears right away. And then you have the central stack. Infrastructure modules, I have no time to talk about those, but that's a trick I needed to get to make it possible to also install software which is common to all 4 partitions, where we say, look, it doesn't matter if you really optimize for the specific CPU, let's install just a single copy of it. Cray PE target modules, that's something very Cray. You set options, the architecture options for the compiler by loading a module. You can also do it via command line arguments, but that's the Cray way. We have our partition modules, we have our software stack modules, then we have those module color module and so on, are modules that you use to change the presentation, and then some default initialization. I do use module extensions, but not extensively, because the Lmod implementation of Cray has no way of hiding them. The implementation is too old, and because module avail doesn't always show the right ones. So for now, these are ones that I have generated by hand. I don't enable it in EasyBuild yet. And then, of course, you have the last page, which is like all the help information that Lmod prints at the end. So how do we work with all this? Well, we have our Cray PE-based tool chains, and they are a further development of the ones used at CSCS. We made various improvements, like a more elegant way of defining the module file. We don't need Lua in our easy config files and so on. Several some additional compiler options, better implementation of the AMD one, and so on. For our easy config files, because they use different tool chains, of course, CSCS is our first source. Our tool chains are modified from CSCS, but remain compatible. And then we also use the EasyBuilder ones. And our experience is that the FOSS easy configs are often very easy to port to the GNU environment of Cray, except if they have all kinds of, I mean, some installations assume that a compiler is called GCC and so on, and that can cause some problems. Our biggest problem is actually that EasyBlocks often don't support Cray. So we follow the CSCS approach most of the time and use generic EasyBlocks with more complicated easy config files, simply because adapting the EasyBlocks can be problematic. We have a maintenance problem there. We can contribute it back to the community, of course, which I know would be appreciated, but then there is no guarantee that if someone else in the community makes changes to them, because the Cray system is not on the list of systems that EasyBuild can easily test with before release, that they will remain working. We can keep them for ourselves, but then if you update the EasyBlock centrally with new elements that may be good for us also, we still need to backport them. So we have a little bit of a maintenance problem there. We do tend to add, and that's something that I've already said, more documentation to the module files, and we do pay a lot of attention to making software more discoverable with module spider and module keyword, which are commands that not enough people know. We did consider using Lmod extension functions for extensions of Python, R, and Perl modules, but we have too many problems with them, partly because of bugs in this specific version of Lmod that Cray uses, that ancient version, partly also because problems that even in the most recent version are not solved yet. We are also not a very great fan of too many small packages because you get very long paths. So that's something that whenever the shell does something, if you're unlucky and it's at the end, has to run through the whole path, which is again, quite a bit of metadata operations. However, we haven't done much about it. In Antwerp, I actually have combined a lot of basic libraries in a single module, but I have not yet done that on LUMI because that might be too confusing for many users. What I did do though is have a build tool modules which bundles all kinds of build tools for a more predictable build environment. If you look at EasyBuild, it has nice easy configs for things like Meson, Ninja, CMake, AutoConf, and so on. But the make, for instance, is always the system make. I use a make which is in there also to be guaranteed of versions of practically all build tools I could come up with. The bundle components remain findable thanks to manual use of extension function and thanks to the use of a whatis line in which I also put them. So with the extension function, you can find them with module spider. With the whatis line, module keyword works also on that. We do all development in user mode, so using our EasyBuild user module, the way a regular user would, and then import them to the contributed or main software stack repositories. And then some of us, like me and one of my colleagues, have a private setup of the full software stack for development and testing before we even try to roll out on the system. But we're still pretty much working on our test setup. So what do I see as upcoming challenges for us in the next year? First, AMD GPUs. They have an immature development tools, immature applications. So we essentially, for information about how Cray plans to do things, we essentially had to look elsewhere to learn about the plans of Cray for AMD support. So we had to look at the early access platform for Frontier, which a week ago published its documentation. So we really only know for a week now that we, for instance, have a naming conflict in our EasyBuild tool chains. We will have to change something there. Moreover, it's still up in the air how installation procedures of applications will support TMD, so how support will appear in auto tools, in CMake, and so on. Another big issue is what with SYCL. SYCL is not officially part of the plans of Cray or AMD. They both push HIP, which is a CUDA clone from AMD, and OpenMP for programming AMD GPUs. But you do see that SYCL might become quite popular with a number of packages, and like the Gromax people are working on a SYCL code path that would replace all code paths except their CUDA code path. Of course, they will still write optimized kernels for different GPU architectures and so on, but they will do so in SYCL except for the NVIDIA GPUs. But that's currently for us a third-party tool, so it remains to be seen how this will integrate. And for instance, how this will also integrate with Cray MPI, or whether we will have to do something different there. And then the other issue is we're only a small team, so what with those packages that require a lot of development, like AI tools, and I don't think I have to tell the EasyBuild community how hard it is to write a working EasyBlock for TensorFlow, or bioinformatics, simply because they have a zoo of small tools, typically with broken installation procedures that assume that each compiler is called GCC, that -m arc equals native is a good option wherever you run, so break cross-compiling, and so on. So these are the three main challenges that I see for us in the next year. So I'm already way over time, so rather than showing more details about how we do things, I would like to conclude. So far, I think EasyBuild deployment has been quite successful on LUMI, but there are, as I showed in my previous slide, several challenges ahead. Of course, it is a very atypical setup because a Cray system is just different in EasyBuild. You work on top of an already installed programming environment rather than managing everything through EasyBuild. You have different tool chains. Even though you are using the GCC compiler, you're using a different tool chain for that. People were first very skeptical about my idea of not installing too much software centrally, but instead making it very friendly to users to install software themselves. But I must say, in the first few months of LUMI, this has worked very well for us. And we already have several successful installations by users simply based on build recipes that we provide to them and tell them, look, you have to run this and this command. And I mean, so far we've got several people, for instance, who have installed VASP already that way. It just works for us. And of course, Lmod is also an important building block of our setup. So when you get a handout of the slides, there will be links in there to our repositories. In the LUMI software stack repository, there is a lot of documentation about how we did things, and many of our easy config files are also documented, have a file in each directory that tells you why we did things certain ways. We may even add some documentation later on how to run on LUMI. We're thinking of doing it in that repository again so that the developers can do it and then pulling it automatically to the regular documentation, but that's work in progress. And then this is the kind of mandatory slide with our sponsors, mainly mentioning Europe and then the region of in which Kayani, the data center where the supercomputer is located, resides. Also seems to be funding quite a bit, so that's the one at the bottom right. And of course, I have to show a picture of the machine to conclude. We've got only the CPU section of the machine and the storage build up, so that's what you see in the left picture. And it's actually built in an old factory hall from a paper mill. So they build a data center inside the hall, which is that structure which is meant to be by the architect to resemble a snowflake. And so inside that structure that you see on the bottom end, you see the computer, which is in the left part of the picture. So thank you for your attention.
Hi, thank you, Kurt, for the talk. If anybody has a question, if you can, and you're in Zoom, can you raise your hand and we'll ask you to unmute. Kenneth to go first. That's peace.
Okay, thank you, Kurt. One question, you mentioned that you're heavily customizing easy blocks, and that creates a bit of a maintenance nightmare. One other way forward could be to use hooks a bit more, where you take full control over any customizations that you need to do for LUMI. And where you can also check things to make sure that some things are not being done, for example, by changes in the easy blocks. Have you considered that? Is that a good way forward?
Well, first, we're not really heavily customizing easy blocks. We're avoiding customizing them by writing more complicated easy config files. So just as CSCS, many of our packages are installed with the CMake or the configure make easy block. Yeah, the generic ones, rather than using the specific easy blocks for those packages. I did configure hooks for EasyBuild, but I'm not a big fan of doing too much with hooks. Before you know, you get a very complicated implementation, and of course you can try to split it in different files with Python and so on, but otherwise you really, I mean, as you saw, one of the big advantages of EasyBuild for me over Spack is that you have those separate files and different users can work on different configurations of a program without merge conflicts. The easy block, you already create more merge conflicts. If you go to a hooks file, you create even more merge conflicts. So that's why I'm not that much fan of hooks.
So the goal is...
I do use them for some things, like I automatically align to each module about where to find EasyBuild support. Yeah. But I'm not a great fan of using them to make too many customizations to software installations. Also, it becomes really hard to figure out where something is done. As a user, you first see the easy config, but then you have to think, I also have to look in the easy block, and then even further, and it's not even documented in the easy block, you have to look in the hook.
Or even other easy blocks, because
Yes.
they depend on each other. Yeah. Do you think there's any generic easy blocks we're missing centrally that would help?
Well, so far I've been able to fix everything with easy blocks, but a more elegant one to really just have kind of a script running, but nicely split up in a configure phase, in a build phase, and in a install phase. Rather than you can now do it, I think with binary or so on, you can fix it and you can give an install command where you can really type the whole command. But having that more split up in several phases may make it a little bit easier and may make it a little bit closer to the EasyBuild philosophy. And then I'm also in favor of having a very powerful bundle easy block. So I fully support that there were some new features added to it. And maybe it might even need a post-install command, for instance, for each of the bundle components.
Yeah. Okay. Yeah, I'll open the floor for some other questions.
Pass across to Bart next.
You're muted, or your microphone is off. I don't hear Bart.
It was the volume of my microphone, probably.
Yep.
So the same thing with Zoom, it puts the volume to 15%. Yeah, just I have a question about the relocatability of the module tree. Does that just apply to the modules themselves, or also to the software? Because I imagine for the software would be very hard.
No, once you've installed the software, you lose that because it puts the path to its install directory everywhere.
Yeah. And there are also a lot of hard-coded paths inside the software, so to make that relocatable would be a humongous effort. Yeah,
I don't even want to try that, but it's really like you have to recompile everything, but we're actually experimenting with easy stack files, but I still need to file a couple of bug reports on them.
Okay.
So the flexibility with easy stack files at the moment.
So the flexibility is just on the module trees, like where the Lua files live, etc.
It's really just in the start. I mean, as soon as you install modules with EasyBuild, EasyBuild also puts full paths in there. But it's like, okay, if you want to start, you want to experiment, you copy your repositories there, and you can, of course, you have to run a script to regenerate to initialize the directory structure. Then you run another script to initialize a specific version of the tool chain, and you can just start using EasyBuild.
Okay, thanks.
In that repository. So I have like 3 bash functions for the 3 different repositories that I manage that way.
Next question from Chris Chang.
Yeah, hi. Can you hear me?
Yes.
Okay. You mentioned one of your responsibilities is writing up user documentation. Do you have a process for deciding what to write up? Because, theoretically, you can spend 24 hours a day writing documentation for users. What do you emphasize?
I know, and there are some people in our team who are way too ambitious in that respect. But we don't. I mean, we're pretty unexperienced team, actually, people coming from 9 different nations, just being assembled a year ago. So it's like, okay, we don't have firm procedures yet. Some people want the documentation on every software package that we had, but I said, look, if you want this, I'm not going to write that because that's going to take too much work. But it's like, it may converge towards, if you have to answer 3 or 4 times the same ticket, then maybe it becomes time to think about making it clearer in your documentation.
Okay. Yeah, we have the same problem, and that's about our approach too. So good to know. Thanks.
Okay.
Then there's still Aachen, I think.
Yeah. The modules adapt that you have, does module spider work as intended for you? I know that PDC is currently having problems with their stack, and they are based on the same Cray PE and the Lmod versions.
It works largely, but I have made a few mistakes during the course of development of the modules that made module spider fail in some cases. Like last week, I fixed another bug that I had, and that in some cases actually module spider failed to show which other modules you had to load. In general, it seems to work quite well, except but that's not just a module spider problem, that's also module avail problem.
Yeah.
Every now and then it looks like Lmod screws up its internal data structures.
Yeah, but you're not using a spider cache, right? Because the Cray delivered Lmod doesn't have that enabled.
I have not tried to install a central spider cache yet, but if you look carefully in your directory in lmod.d/.cache, it actually builds something which looks a hell of a lot like a spider cache.
Perhaps I haven't
but
looked
it's
at
also
the
on
PDC
user
system.
level, and so if you have problems with so it's like erase that file and let it build it up again.
Yeah. I mean for the central setup.
But I haven't tried the central one yet. Yeah. It's on my to-do list, but
yeah, because Henrik at PDC was asking me questions about how to. He has problems with module avail showing modules that shouldn't be available because they haven't loaded the PDC corresponding LUMI.
I haven't had that with modules, but I do have that problem with extensions.
Yeah,
that's one of the reasons why I do not want that extension list that Build Tools was available, so it should have shown the extensions, but quite often I have that extension list while the modules of which they are an extension are not yet available. So module avail doesn't seem to work for extensions. And that's not just a problem of Cray Lmod, that seems to be a problem of many newer versions also. I haven't tried with 8.6 yet, but I had it with various 8.5 releases also.
Yeah, but this was not extensions, this was just pure standard modules.
Yeah, that I haven't had yet.
Yeah, I'm going to take a look at their system later.
Of course, they may have copied the bug from me that I have corrected since then.
Yeah, since they based it on what you did.
Yeah, they based it from my code, I know.
Yeah, I'll take a look later. Thanks.
Does anybody else have a question at this point?
Any questions in Slack worth raising here? There was a bit of chatter, or maybe in Zoom.
What's your hook remark in this? There is that remark about it's never too early to let the kids start working with EasyBuild. Well, in Leuven, this is the case. Maybe I should post some photos later on in the workshop, but at several schools in Leuven, they painted 3 blocks on the road that look a little bit like the EasyBuild blocks, except that the colors are in a different order. So it's kind of fun to see. The first time I saw that my reaction was, hey, why do they make advertisements for EasyBuild here at the school? But it seems to be something typical for Leuven, and they have 2 versions of it. They have the full version, but nowadays they save on paint and they just draw the circumference of the cube.
Okay, if there's no additional questions, we should wrap it up here, Simon, and switch the stream.
Yes.